Hello, my name is Asbjørn Torvanger. I'm with the CICERO, which is the Center for International Climate Research. Today I will talk about governance provisions and challenges of large-scale deployment of bioenergy with CCS, so-called BECCS. And I will actually focus on two topics, where the first one is what is the potential? How big, in other words, can BECCS be in more physical terms? And second, given that this has some potential, how could that potential be realized? And in that case, what are the kind of major governance issues related to BECCS? So BECCS has to deliver on many stages because it needs to be sustainable. We need to achieve these negative emissions, and it needs to be viable. So this is illustrated in this graph. We need a sustainable production of bioenergy or biomass for bioenergy. We also need efficient conversion from biomass to energy. This is also an issue of available land use because there's always competition in terms of various land uses. We need also efficient carbon capture and storage. So this is illustrated in the small area in the middle, dark green area in the middle. In addition to this, of course, we need to involve industry. So there must be incentives for industry to participate in that. And all this must fit into the global climate regime. And specifically, of course, the Paris Agreement. So how much BECCS do we need? Well, obviously that depends on what scenarios we are looking at in terms of climate target, in terms of energy systems, negative emissions, etc., etc. This is an illustration from a colleague of mine, Glenn Peters, showing how much BECCS we need throughout this century. And what we can see is, of course, that there's a big variation, but what we see is that if you really want to aim for the Paris Agreement target of less than 2-degree warming and pursuing 1.5, which is the blue area, we are talking about huge amounts of BECCS as an important negative emission technology. And actually, this is approaching the level of current global emissions of carbon dioxide by end of this century. And today we only have a few BECCS operations. I should first mention the Illinois Basin Decatur in the United States, where ethanol is captured from fermentation of corn. And about 1 million tons of CO2 is stored in sandstone every year. But there are also a few other plants in Canada and Netherlands. Most of this is fermentation based on corn and producing ethanol. And actually 3 of these are using the captured CO2 for more oil production, so-called enhanced oil recovery. So what is the scalability of BECCS? Well, if you want to do BECCS as a major climate technology, then we are talking about huge need of land. For instance, something like 7 to 25% of global agricultural land. And also note a fair share of global water use. In this study, Smith et al. 2015, we found 3% of global water use. Furthermore, there is something we could call a carbon cycle rebound effect, which means that if you remove 1 ton of CO2 from the atmosphere, the concentration of the atmosphere of CO2 will be reduced less than 1 ton. And that is because we are then doing something with a dynamic system where there are these streams of CO2 between biosphere, the ocean, and the atmosphere. So if you remove some from the atmosphere, this will affect also the other streams. And you could think of this as less. When you remove CO2 from the atmosphere, less will be absorbed by the oceans. BECCS will work in technical and economic terms, but it's expensive. And then there are many governance and sustainability issues, which I will come back to. So the big issue is then, to what extent is this feasible and realistic in political and societal terms? So the first issue then, going more into details, is on the accounting of bioenergy, because this is about negative emissions, and negative emissions is not the same as avoided emissions. So what will be the net CO2 removal? Because we need to produce the biomass, for instance, forest timber to be used, we need to transport it. It needs to be processed into bioenergy. And we, as I mentioned, we also have the rebound effect. So what is the net CO2 removal effect? So this affects land use, life cycle. For instance, how much do we account for resources uses for the processing of biomass to bioenergy? What about the regrowth of the forest or the land? What about carbon stored in vegetation or in the soil, which will obviously be affected? And will this energy be additional, or will it replace fossil fuels? So there is a land use competition here with local use, crops, ecosystems, biodiversity, etc. How much should we then include in terms of life cycle assessment, for instance, on processing biomass to bioenergy? And also remember that in terms of carbon capture and storage, it's not possible realistically to capture 100% because that will be too expensive and difficult. So realistically, we are talking about 90% of CO2 captured. You also need then to monitor the stored CO2 in geological formations, and we need contingency plans in case of leakage. I should add that the leakage risk, if you choose the right or the best location, is very small. We also need a rule book on CO2 transportation between countries, because that could be a part of a global scheme of biomass for bioenergy and CCS BECCS. One difficulty is that emissions are commonly reported by sector, for instance, transportation or energy sector, as one, and this is independent of biomass and agriculture accounting or reporting. Whereas we are, of course, in this case with BECCS, we see that we need to combine the biomass in the agriculture sector with the energy sector. So this makes it hard to calculate the net effect on CO2. And in those terms, project-based accounting is better. Next question, rewarding BECCS, because we need to incentivize industry to participate in that. So one kind of challenging issue is that since we have this, what I call the rebound effect, should we have a discounting due to how carbon removal from the atmosphere interacts with the carbon cycle? On the other hand, BECCS could have an additional value if we in the future are in a kind of overshoot situation. That is, we are actually have too high global emissions or too high concentration in the atmosphere, and we really need to reduce the concentration in the atmosphere. Whatever we do with the emissions, we need to reduce the atmospheric concentration. We also know that the cost of BECCS is much higher than the present value. Just to mention a couple of numbers here, if you look into the studies, the cost of BECCS is estimated at something between $70 or $250 a ton of CO2. And you can then compare this to the allowance price per ton in the European emissions trading system at $29 per ton of CO2 currently. So as you can see, there's a huge gap there. There is also a significant risk for industry investments. So do not expect that the industry will engage with this currently, because as you can see, there's really a huge cost benefit or value gap. So that's why we need substantial government support needed, not only in terms of the framework for this to work, but also in terms of, at least for some years, money terms. The need for this support will be eventually be reduced when the international carbon price picks up. And if you start deploying BECCS, there will be learning effects and upscaling effects that will lead to cost reductions. BECCS also needs to be aligned with the market mechanisms. And today, the situation is that the ability to handle negative emissions vary substantially according to what system we are talking about. For instance, CO2 emissions trading systems. And it also then depends on how things like forest and land use are handled and how carbon capture and storage is handled. One example, for instance, is that it's presently not possible to account for negative emissions in the European emissions trading system because biomass is included in the baseline, or you can also say that biomass entities are completely excluded from this emissions trading system. So if you instead have a more project-based approach and schemes, it's easier to include negative emissions from BECCS. And one kind of model for this could be the clean development mechanism from the Kyoto Protocol. But I do believe that accounting and the rules for BECCS should be more standardized and simpler than what we have done in terms of the clean development mechanism, which became very complex and expensive. BECCS could be included as a kind of credits or a net back, where in the latter case it's subtracted from positive emissions from a sector in a kind of broad emissions portfolio. The CDM variant would be a more credits approach to accounting. So what about the Paris Agreement? Well, we do see that there is a larger opening than for sinks, negative emissions also than in the Paris Agreement compared to the Kyoto Protocol. If you go to Article 5.1, it states that we should conserve and enhance as appropriate sinks and reservoirs of greenhouse gases. In the Paris Agreement, we also have these trading mechanisms in Article 6.2 and 6.4. And obviously, these should relate to negative emissions and also to BECCS. This should be part of the rule book associated with the Paris Agreement, where the modalities for negative emissions needs to be developed. And this needs also to be part of reporting of actions under the nationally determined contributions of the parties to the Paris Agreement. And as I said, I think there is useful experience from the CDM to be gained here. And whatever we do, we need to have a balance between what you can say is the kind of perfect solution, but which will be very complex and expensive, and what is lower ambitions in terms of being efficient, operational, and realistic. So let me end off then with BECCS. What is the way forward? Well, I've talked about the fiscal limitations and the governance limitations and so on, especially related then to land use. So in my mind, BECCS will only have a limited and regional scale of potential. It will not be the silver bullet, not in climate policies or climate technologies, and neither in terms of negative emission technologies. But it can do some of the task or some of the work needed. We need to adopt a standardized framework for doing sustainable biomass, which is an essential part of BECCS. We also need to adopt a standardized framework for accounting and rewarding BECCS. Open for discussion is still if they should be valued at the carbon price or if there should be some kind of discounting, as I mentioned, because we have this carbon cycle rebound effect. Definitely, we need early government support to enable business engagement into BECCS, because there is no business in this presently. The cost is much higher than the value. Also important to remember to maximize learning across BECCS applications and also the other negative emission technologies. Because for many of these, there are some components that are overlapping. And finally, we should align BECCS development with Paris Agreement and the modalities under the Paris Agreement, and especially the market mechanisms. Thank you for the attention.